this fourth analytical geometry video, we are going to just do a proof, but using analytical methods. So in this case, you're given a quadrilateral ABCD, and you're given the coordinates of all of the vertices, and the question is, what type of quadrilateral is this? Prove your answer using analytical methods. Now, sometimes the question will be open-ended like this. Sometimes they might say to you, prove that this is a parallelogram, a rectangle, a square, whatever the case might be. Okay, so the first thing we're going to do is I'm going to examine to see if this is potentially going to be a parallelogram. And for a parallelogram, the easiest way to see whether or not it's a parallelogram to see if the diagonals bisect each other. So I'm going to start off here by working out the midpoint of AC. Might be easier just to write in our ordered pairs here, minus 1, 2. C is the ordered pair 6 and 1. B is the ordered pair 3 and minus 2. And D is the ordered pair 2 and 5. So if I'm working out the midpoint of AC, I'm going to add my x's and divide by 2. I'm going to add my y's and divide by 2. And so the midpoint of AC becomes 5 over 2, 3 over 2. If I now work out the midpoint of BD, same process, 3 plus 2 and minus 2 plus 5. I land up with 5 over 2 and 3 over 2. The fact that those midpoints of the diagonals are the same means that the diagonals bisect each other. So therefore I can draw the conclusion that ABCD is a parallelogram. And why is it a parallelogram? Because the diagonals bisect each other. Okay, so let's investigate a little bit further and see if potentially ABCD could be a rectangle. Well, if it's going to be a rectangle, it means that it would have to have a right angle. And so let's examine that. How do we find out if there's a right angle? Well, I'm going to work out the gradient of AB, 2 minus minus 2, difference in y, over minus 1 minus 3. Okay, that is going to give me a 4 over a minus 4. The gradient there is going to be minus 1. If I work out the gradient of BC, again, difference in y's, I'm going to say 1 minus minus 2 all over 6 minus 3, 3 over 3, which is 1. Okay, the gradient, taking this piece of information, the gradient of AB multiplied by the gradient of BC is going to equal minus 1 times 1, which is negative 1. If the product of those gradients is minus 1, we can conclude that AB is perpendicular to BC. So now we know that ABCD is not just a parallelogram, it's more special than that. ABCD is a rectangle. Okay, it's a rectangle. Why? Because we have a right angle. Okay, well, shall we see if maybe ABCD happens to be a rhombus? And probably the easiest way of checking to see if it's a rhombus is to see if our diagonals bisect each other at 90. Or what we can do is we can work out lengths. And I'm going to use lengths in this case just so that I've gone through a number of different formulae. So if I work out now the length of AB, Well, AB squared would equal the difference between my x's squared, minus 1 minus 3 squared, plus 2 minus minus 2 squared. Minus 4 squared is 16, 4 squared is 16, and that length AB will be equal to the square root of 32. If I was to work out the length of BC, I do need to check an adjacent pair of sides. Okay, it would be the difference between my x's, 6 minus 3 squared, plus 1 minus minus 2 squared. 6 minus 3 is 3, 3 squared is 9, 1 plus 2 is 3, 3 squared is 9. Okay, so in other words, the length of BC would be the square root of 18. This is clearly not going to be a rhombus because we do not have adjacent sides equal to each other. So the most that I could say about ABCD is that it is a rectangle. Okay, it is not a rhombus. And the reason adjacent sides are not